A warm welcome to our web seminar, IT Project Test. My name is Thomas Rönnpage. I'm Sales and Business Consultant with Verum Software and Systems, and I would like to tell you about digitalization in testing in the next 30 minutes, as it is a real interesting IT project. There's a number of challenges test departments are facing today. Obsolescences occur unexpectedly with hardware and software. The units under test grow more and more complex, and quality requirements are increasing steadily. As every new function needs to be tested, such as wireless communication protocols or other digital interfaces, the variety of test beds increases continually and can hardly be mastered by the existing personnel. Test orders, production orders, and bills of material are managed in ERP or PLM systems, although this type of system is not intended for tasks in the environment of testing, and the test staff does not really like working with them. There are still many manual processes, different data formats, and diverse test systems. In every test department, there are many approaches to increasing efficiency. If you want to rise to all these challenges, you need to start a digitalization initiative. But let's first have a look at the single challenges in detail. A test department is concerned with the topic of obsolescence, not only if hardware fails or replacement parts are unavailable, but also in other situations. As a result of continually increasing numbers of test orders and the requirement to archive more and more data for the long term due to verification duties, many local databases are stretched to their limits. The access times resulting from this circumstance damp down operations efficiency in the test department. In fact, there are real examples where the access times range between 5 to 25 minutes, which actually renders them useless. Another challenge a test department has to face is the growing influence of corporate IT rules. While it was quite common in the past for test departments to run their own software solutions separately from the corporate IT, most companies today have mandatory IT rules that also apply to the test departments. As IT departments too are interested in improving efficiency, the software solutions used in a company are consolidated. The result frequently is that the software used in the test departments is no longer supported by the corporate IT and that they have to change to other tools. In addition to this, there are security gaps that put an end to the employment of old software. Especially in this area, we could mention many examples of old Windows XP computers that are still running in the test departments. Also, operating system updates carried out across the whole company affect test departments. Many companies introduce management software solutions for quality assurance or KPI calculation purposes, which are not compatible with the legacy systems existing in the test departments. There also are many individual software solutions test departments have developed in the course of many years to support their workflows. Many of these individual software solutions were set up using old software development environments that are no longer supported. Also, the software developers themselves who created the individual software solution and maintained them for many years often retire, and many companies don't want their test department to employ software developers. What all these challenges call for is a future-proof, consistent, open standard solution. The second major challenge for a test department is the steadily growing complexity of the units under test, which results in increasing numbers of test and test orders. This continually increasing number of tests is difficult to cover with the existing testbed capacities and test personnel. That is why the requirements on test planning and adherence to schedules become stricter. The growing complexity of units under test also causes the quantities of acquired test data to increase continually. Moreover, it was sufficient in the past to archive some key values of the test. Today, it is desirable to keep the entire measured values of the test for a long period, that is 5 or 10 years, in order to fulfill increasing verification duties. As a result of the growing complexity of the units under test, the actual test process is getting more and more complex. Either more departments and people are involved because, for example, simulations, model in the loop, software and hardware in the loop, and other methods are used. As it is not possible to enlarge a test department at will, and no unlimited number of personnel resources is available, we must succeed in optimizing the number of test orders and their execution. A suitable test management software is able to detect redundant tests and to group several tests in one test order. This way, setup times can be optimized and resources can be utilized more efficiently. On the one hand, units under test grow more and more complex and increase the test quantity. On the other hand, customer requirements keep raising the test quality. In case of customer complaints about the product quality at a later date, you would of course like to furnish exact proof of what was tested, at what time, with which means, and under which conditions. Did all the measurement devices used have valid calibration certificates? Did the employees who executed the test have the necessary qualifications? These questions are also relevant if the test department wants to work by a quality standard such as ISO 17025. Observance of the required processes and context-related storage of the entire data can be mapped in a suitable IT tool. Also, integrating the test processes into the corporate IT becomes more and more important. Many companies already have corporate ERP systems to manage their entire resources, like measurement devices, test beds, units under test, etc., together with the cost centers. Bills of material, though, reside in PLM systems. Test requirements are managed in requirements management tools and must be transferred to the test order. Any modifications made by the test department must be reported back to the requirements management tool. Orders to produce units under test or auxiliary equipment have to be created in the usually unpopular ERP system. Frequently, separate systems are employed for warehouse management purposes. That means that the test department staff has different tools to work with, and the tools often don't have any internal interface. And what is more, the management and controlling units are interested in KPI data or testbed utilization, adherence to schedule, and similar information because of their endeavor to optimize efficiency. Often, LIMS systems are introduced in order to improve quality, but in many cases, they are incompatible with the test laboratory's existing measurement system. So it happens fairly often that the LIMS system is able to manage the acquired measured data, but they can't be visualized because the measurement data acquisition system supplies them in a proprietary data format. The fact that the test department staff have to work with a variety of different software tools has a negative effect on their productivity. In a perfect world, all employees involved in testing would work with only one software tool, which is an integration platform that supports interfaces to all software solutions involved and allows for operation free of any media breaks. Generally speaking, there are many parts in the processes of a test department that don't really run smoothly. Test orders, for example, are created in the ERP system and transferred manually to the testbed. Not really the optimum solution if you look at it from a quality and efficiency point of view. If the data of tests executed in the past are needed because of returns or for comparison purposes, it often happens that they can't be found or are useless because the documentation on the test conditions is missing. Sometimes the information that a similar test was already executed at a different site is not available because the data can't be accessed. The result, unfortunately, are time-consuming and costly repetitions. A uniform and comprehensive view of the data can improve efficiency to a significant degree. Also, the system variety we mentioned earlier, with its incompatibilities and different operating concepts, is a major challenge for test departments. It takes the operator a lot of energy and time to think their way into the different operating concepts of all the newly invented test system, and it goes without saying that they make mistakes. Especially in the workshop and assembly area, there are many users with an extremely low affinity for IT. So, a consistent solution with a uniform operating concept is what the users actually wish for. The expanding function range of units under test leads to an increase in the number of test beds. Most testbed suppliers cover only a part of the functional test. Therefore, it is difficult to employ testbeds by only one manufacturer. The more common situation is that you find a large variety of diverse testbeds for the different test tasks. Every testbed manufacturer have their own test automation concept and offer different interfaces. The data exchange over these interfaces also is very individual and often proprietary. Some manufacturers support standards like OPC UA, while others provide proprietary DLLs, use a file share to exchange data, provide web services, or don't offer any interface for the data exchange purposes at all. This large variety of interfaces, data formats, and local test automations makes it extremely difficult to achieve a uniform integration of test beds into a higher level test management system, and maintaining them is hardly possible. The different operating concepts of the individual testbed manufacturers make it impossible for the staff to operate all testbeds properly, which rules out flexible personal planning. If you want to meet today's requirements on quality and efficiency, a uniform integration into test planning and test data management is advisable, just like a standardized operating concept. With this slide, I'd like to illustrate the challenges a test department is facing. There are many testbeds by different testbed manufacturers. Every testbed stores its metadata locally in a frequently proprietary format. Some testbeds are able to store their data on a central network drive or in a database. Here too, every testbed uses its own data format, and the method of storing metadata depends on the individual testbed. Usually, every manufacturer has their own individual testbed automation. When it comes to resource management, transferring test orders, bills of materials, or some other details, the test department is reliant on corporate IT systems like ERP or PLM and has to work by their workflows, which are not adapted for testing operations. The test department too uses many individual solutions to manage test orders, measurement equipment, and test procedures, to plan the utilization of tests and personal capacities, to analyze data and generate reports, or to assure quality. Interfaces are required to connect the test beds to test planning and test data management. Testbed manufacturers usually offer different, mostly proprietary interfaces. There also are many different mechanisms for communication, like web services, file stores, databases, etc. A first essential step towards improving efficiency and quality in the test field is to introduce a consistent software solution that covers the entire test process, from test planning through to test data management. In a second step, a universal testbed adapter could be introduced, which makes it possible to integrate the testbeds into the test process without any media breaks. With our standard solution, HyperTest Boost, we from Verum support the entire process of test planning and data management. Due to its modular architecture, it can be adapted to the individual case of application. HyperTest Boost provides all users in the test and in the development departments with a uniform operating concept based on web clients, which leads to a significant improvement of efficiency, as training efforts can be reduced and the staff has only one software solution to process virtually any task. The powerful roles and rights management makes sure that only qualified personnel can grant release or access findings. It also takes an effect on the data displays. So, the roles and rights management also contributes support in meeting quality standards like ISO 17025 or ASPICE, actually ISO IEC 15504. The completely context-related data storage enables 100% traceability of tests and therefore supports verification duties. Moreover, it is an essential function to avoid redundant test tasks, thereby increasing the efficiency of test orders. The fact that there is no media break in the entire process, from the request through to the result report, improves the quality in testing considerably, as errors in manual processes can be prevented. With the open architecture of HyperTest Boost, A JSON interface or REST API can be used to digitally connect test beds and integrate them into the test process. Another possibility to achieve significant gains in efficiency. It is also possible to integrate them into corporate IT so that ERP, PLM, or requirements engineering tools can seamlessly be connected to the test process. Production orders for units under test or accessories, for example, often need to be created in an ERP system. Instead, you could create them in Hypertest Boost and have them automatically transferred to the ERP system. So almost all the tasks involved can be done using one and the same software, a fact that clearly suits to win users over. There also are different approaches towards global scaling. It does not only allow planning teams to access all sites and resources across the globe, it also makes it possible to see all tests that have ever been executed. A good way to prevent redundant test orders or to visualize quality comparisons between sites at a push of a button. With the next slides, I'd like to go into the details of the test process as we have mapped it in Hypertest Boost. The test process starts with the requirements management. Test requirements are imported from a requirements engineering tool or are acquired manually. Hypertest Boost manages them, thereby enabling traceability. The user accesses the requirements and decides if they need to be verified by a physical test. It is possible to group tests, and the user is provided with a clear overview to control the test coverage. The next step is the request management. It includes the rough planning of resources and schedules, the definition of test parameters, and test procedures. The next step of the test process is about planning. First, the test plan is scheduled, including all times, resources, procedures, and milestones. Additionally, a test offer can be created, covering the test plan and the cost. Once the planning is complete, a test order is generated. Resources are assigned, such as unit under test, testbed, test equipment, and so on. Workflow plans, tasks, and execution lists are created. Resource descriptions, bill of materials, single parts, assembly states, and installation locations are managed. And upstream and downstream activities are acquired. As part of the test execution step, Hypertest Boost transfers test orders to the test bed and supports upstream and downstream activities. It manages to-do lists for the employees and supports parallel activities. Hypertest Boost supports the staff in executing the test by maintaining a list of their tasks. The operator may acquire measured values manually in Hypertest Boost. Further, the test status can be displayed. Depending on the automation system, Hypertest Boost also supports automatic test execution. Prior to, during, and after test execution, Hypertest Boost supports the documentation with texts, images, and files. At the end of the test execution, the test data are imported. That means, for example, that they are fetched from a pickup folder. In case of durability testing or tests of generally long duration, the data are transferred continually during execution. In the analysis step, Hypertest supports the automatic harmonization of the data imported, for example in terms of units and data formats. To obtain a quick overview for assessment purposes, a graphical preview of the data can be displayed. External analysis tools can be integrated for automatic data processing. Usually, a test report is created at the end of a test. Here, Hypertest Boost supports the automated generation of test reports based on templates. For simple reports, a Microsoft Word template can be used. For specialized reports, Jaspersoft Studio is a suitable tool. In its capacity as information management system, Hypertest Boost places available all reports and results which suits to prevent redundant test orders. Hypertest Boost supports global queries by any required context according to the defined roles and rights. The powerful dashboard can be used to visualize data based on charts and tables. It also allows for individual visualization schemes for any required data. That also includes the configuration of management views like testbed utilization or adherence to schedules. You can map the whole test process using the standardized software tool Hypertest Boost for digitalization. And this way, significantly improve the quality and efficiency of your testing operations. In the next step, I would like to elaborate on vertical digitalization down to the testbed, which is facilitated by a universal testbed adapter. With Hypertest TBA, we at Verum have created a universal testbed adapter that makes it possible to efficiently integrate testbeds into the test process. An individual integration of every single testbed into test planning and test data management causes tremendous efforts for implementation and later on maintenance, whereas Hypertest TBA is integrated only once as a central interface. All it needs is to individually connect the testbed adapter to the different testbeds. The centralized development and maintenance of the testbed adapter means a significant improvement of quality, as all testbeds use the same version and profit from the same updates at the same time. In addition, the database available with error messages is wider. With Hypertest TBA, all testbeds get the same ordering workflow, which leads to an increased acceptance with the users and enables flexible personnel assignment. Even in case of simple testbeds that don't have any interface, the same user interface are used to transfer test orders from the test planning and to release test data to the test data management. The connection of the test planning to the test bed and back to the test data management is free of media breaks, which prevents errors and improves the quality of the result data considerably. Hypertest TBA can turn simple test beds into smart test beds, and it can even provide them with a user interface. Hypertest TBA acts as mediator between systems and connects the individual systems using plugin modules. There's a plugin module for user login and central identification to connected systems. Another plugin collects orders from the test planning of the test management system. Converting the test order format for the individual local test automation of the testbed is also done by a plugin module. On completion of the test execution, the result data are compiled and they are converted into the format of the test data management system. This also includes the normalization of names, units, and formats. Hypertest TBA performs the data analysis and report generation directly on the testbed, so the validated and quality assured data are passed on to the test data management. The separate user interface provides a uniform view of the test orders. This modular data hub makes it possible to efficiently integrate the most diverse testbeds. This is how Hypertest TBA increases quality and efficiency in the digital integration of test beds into the test process. By introducing the platform solutions for test management and testbed adoption, you have now a media break-free solution for your test process that meet highest quality requirements. The automated workflows improve efficiency significantly, and the uniform operating concept leads to increased acceptance by the users. In the past, for example, users in the test department had to create production orders directly in the usually disliked ERP system. Now they can see virtually all their tasks in the test management system. Also, the integration of the different test beds has become much easier with the testbed adapter, and the uniform operating concept is a strong support for the users. In order to increase test efficiency on the testbed, the third platform Verum offers is WTCS. WTCS is an extremely powerful testbed automation system and can be used with testbeds where the manufacturer provides for the integration of other automation solutions by defining and describing the relevant interfaces. With WTCS, Verum has designed a comprehensive platform that by default covers many aspects of state-of-the-art testbed automation. WTCS facilitates the collaboration of testbed operator and testbed customer and integrates all subsystems. Essential parts of WTCS are adapted to the individual testbeds simply by configuring them so that only a few adjustments really require individual programming. WTCS provides for full manual control of all subsystems and for fully automated test operation. As far as quality and efficiency are concerned, WTCS2 has a powerful data management that combines the metadata of the test description with the data produced in the automation system and the local data of the subsystems. An important, convenient function of WTCS to assure quality and find errors are the manual operating options. For every subsystem connected to the testbed automation, there is a separate operating dialog to operate it manually. The required commands are sent to the subsystems concerned. To improve quality, the acquired test data are validated online and can be compared in a table of target and actual values. Events and alarms that occurred appear in the corresponding status display and can be edited. The local test management of WTCS supports the creation, execution, and management of tests. The data model can be adjusted and expanded. The table dialogs correspond to the data model. A wide range of display options is supported so that most diverse contents can be displayed in a suitable layout. It is also possible to integrate graphical dialogues. The test sequencer, which eventually executes the test steps, is an integral part of WTCS. Simple as well as complex test runs can be configured in WTCS. It is also possible to run nested loops. The test runs can be saved for reload. The test environment, with its participating and controlled systems, is defined either. To provide for quality assurance, the test runs created first appear in a preview to check them and make manual adjustments if necessary. When test runs are executed, their progress is monitored and intervention is possible. For example, pause execution, resume it, or terminate it for good. At the end of our presentation, let me give a brief summary of what we found out. The only way to meet the challenges test departments are facing today, which are basically caused by continuously increasing product complexity and quality requirements, is a real efficiency initiative. Such an efficiency initiative is a comprehensive IT project in testing that takes only adequate effort and high-performant platforms to implement a future-proof solution. Harmonizing the IT support in the test department achieves a significant improvement of efficiency and quality along the entire test process and involving the test beds. A holistic, seamless IT approach makes it possible to cope with today's and future challenges and to help the staff involved in testing achieve better results. So far, we have seen how a platform concept can improve quality and efficiency in testing. This brings up the question of how the implementation of such a concept can work out and achieve maximum success. We at Verum have supported many enterprises in converting their existing systems into a platform concept. Here, pursuing an agile approach has proven successful. Especially when it comes to system analysis, it is extremely important to establish a connection between users and IT. Here we can ask the right questions to support users as non-IT specialists in the software rollout phase. The users always can yield valuable information on user experience. In order to gather first experiences with the new system, a proof of concept has turned out to be a good idea. The users can try the system, and a requirement specification for the overall system can be created in joint cooperation. The fact that the overall concept is agreed between user, IT department, and Verum brings about the best possible mutual understanding, which ensures the implementation to be crowned with success. The overall concept is based on many considerations. What happens to the existing data? Should they be migrated? Is a read only on the existing data enough? Or should the old application continue to be used to show the existing data? Milestones are commonly agreed in order to accomplish a smooth changeover. Another part of the overall concept is the scaling of the system. Frequently, scaling is important not only in terms of the own site, but other sites located all across the globe need to be considered when changing the system. So if you start by transferring one specific product line to the new system, for example, you have to consider the entire international sites testing this product line. The scaling concept also needs to take mutual access options into account. Another question to be asked when creating the overall concept is if the application should run on-premise or in the cloud. We can help taking this decision based on our experience as well. A major point for discussion, last but not least, is the question of who should be hosting the system. The latest trend is to outsource operations and to purchase infrastructure as a service. You are welcome to contact us if you want to know more about it. We would be happy to support your enterprise in increasing the efficiency of your test department. With this, I hope you've enjoyed our web seminar. If you would like to learn more about us, you are welcome to visit our homepage or to contact us at the given addresses. Thank you very much for your attention.